Good day from ChemHelp ASAP. This is our second video that is really a high-level introduction to the ideas of energy, bonding, and orbitals. So we've talked about how bonding leads to an energetically favorable state, and how do we portray that? Well, what we'll do pretty frequently is we'll draw this axis, and this axis is meant to represent energy. You can think of it as a y-axis if you want. And then when we take our atomic orbitals, we need to put them somewhere on this y-axis. So let's just say arbitrarily, here is an atomic orbital, and it has this particular level that we're showing on the axis. It's in, right in about the middle of the axis. And then we're going to mix atomic orbitals. So let's put another orbital. Let's not put it at the same place, but they're typically always shown about the middle of the axis. And let's assume we're still talking about HCl. And we're going to mix these two. So let's say this is our atomic orbital for hydrogen. It has an electron in it. And over here is an atomic orbital from chlorine, and it has an unpaired electron in it. And when these mix, the mixing is shown in the middle. And we generate new orbitals. So on the left and the right, this is kind of the before. So before the bond forms, you have these atomic orbitals. And as we move to the middle, this is the after. So in the middle, this is where we've made our HCl bond. Now, there are two new molecular orbitals. What happens to our electrons? Well, the electrons want to go to the lowest state that they can find. So our electrons, whether it comes from the left or the right, from the hydrogen to the chlorine, they're both going to go to the lowest energy possible. And this is why this is a favorable process. These electrons go downhill in energy. They have a drop in energy, change in energy, and it's lower in energy. Now, what's often forgotten is the fact that we made a second molecular orbital. This is formed. We can't destroy orbitals. If we put in two atomic orbitals, we got to get out two molecular orbitals. Sometimes we will talk about this orbital. So this lower orbital is called the bonding orbital, and this is the anti-bonding orbital. You might think, what good is an empty orbital? Who cares? There are no electrons there. Well, sometimes it's a place where we put electrons. Now, let's talk about a more pictorial representation of the orbitals, not this energy picture. So we've seen things like s orbitals and p orbitals. Here is a fancy picture of an s orbital. I'm going to say it's shaded. And here is a p orbital. Now, p orbitals have one side shaded, one not. We're getting to the mathematical sign of the orbital. So orbitals are actually mathematical equations. They're called psi. They're called not mathematical equations, but they're mathematical functions. These are the wave functions. So when I say the p orbital has a shaded side and an unshaded side, what I'm saying is, mathematically speaking, there's a positive and negative side to the p orbital. Now, that is not a chemical charge. That's not an electronic charge. It's just a mathematical sign. The mathematical equation can give a negative and positive value. It's not charge from electrons. So when we mix these orbitals, this is what we mix. We mix the wave functions. These are mathematical functions. We can add them and subtract them. Now, in contrast, we'll also sometimes see what we call probability functions. These are called psi squared. Now, when you square, going back to the top of the p orbital, when we square this negative value, it becomes positive. So when you see the psi squared, the probability functions, everything will be shaded. This is more, we don't tend to mix probability functions. We draw these to know where the electron is. What is the shape of the orbital? When people talk about the shape of the orbital, they're talking about the probability functions. Where is that electron going to reside around that atom? Up top, the wave functions, these are the equations that we add and subtract. They're different. It's subtle, but they are different. So that's a little bit more in-depth picture. These two images that we've shown, this axis for energy and these kind of blobbish pictures to represent orbitals, these are the pictures that we're going to see quite a bit of as we continue to talk about covalent bonding in organic molecules.